Hello from Romania, from our favorite artist electronist, Mr. Q12, the greatest. Do you like my introductions? Today I want to discuss about analog to digital converters, also named as ADC, and I will discuss about one single ADC, namely ADC0808. It is a parallel input and parallel output integrated circuit. And it's very important, this little detail, this little functionality, especially when you choose what you want to use in your design, is very, very important. This is the intro. What type of ADC it is parallel or serial input, and what type of output is having parallel or serial output. So that's very important. So this guy is having parallel in and parallel out, pins. I started using this chip here in the simulation in the Proteus. I don't have it yet. I buy it already and it's on its way. But until it will arrive, I will still have to make it work. So right now, in this moment, what you are seeing here is this is an old save file that I'm having. This file was made for ADC0832, this guy here, which is serial in, serial out. And I still didn't manage to make it work properly yet. But I did concentrate on this simpler one, the ADC0808. I wanted it commanded from an Arduino and not from logic, simple logic that we are seeing here in this example. So I made a new file only for this chip that I'm having here, only for this simulation, to actually see it running smoothly, because if I'm having too much stuff in the same save file, it will not be as fast. If I'm moving this potentiometer here, you can see on the fly how everything is updating. And I love this functionality. Originally, when I came across on this chip, I had this circuit diagram, and you had to actually make it high from here one time. And if I'm changing now the potentiometer that I'm having it linked to all these three chips is sharing the same potentiometer that I'm having here, is really doing the same thing, absolutely the same thing as the other. This is not linked to Arduino, and the purpose of this movie is to show you a little bit of background, a little bit of history. You get the functionality, how it's working. When I'm moving this potentiometer, it is updating on the fly, everything, and it's pretty awesome. It's very good. This pins start and end of conversion, EOC, are linked together by this common wire in this setup that I'm having right here. But in Arduino, I will have to use a special setup. I will have to link them differently. So this is it about this file. I wanted to show you a little bit of history, like I said. And right now, right here, I have, let me actually go here. And I have all these tests. No, I have only one file for Arduino, but I did a lot of tests, inside this file, which is this file. So in this file, I made a ton of tests. And then these are the tests that I did for the Arduino program. It's not really straightforward what I did in all this experimentation that I did here, but suffice it to say that I really get the results that I wanted. Is pretty good right now. It's very, very good. The behavior and the code and the circuit that is running. So right now, I had to play a lot with the circuit diagram. So I couldn't figure out how to link this ADC, this chip, to the Arduino. So I had to try numerous permutation, a lot of trying and errors, and scratch my head and bump my head to the walls. And I didn't know how to do it in any way. But I stick with it like a couple of days, probably 1 week. But I'm not sure. A couple of days until I figured it out. And this is what I originally figured out, how it should work without this link, as you've seen in the other. So this is not linked here, but I noticed on this pin that is exposing, it is sending a signal. So let me play it a little bit. What? I don't have the, I have a special. So before starting anything, I have to open the file, the code. Arduino code file, because you see it here, I have a special setup here for this terminal to work. And what I mean by terminal is this guy here that is called the terminal here in Proteus. And for this terminal to work, I must load Arduino with the hex, with the .hex from this specific root that I'm having it there. Every time you start the program, but it will read every compilation from Arduino after that. Very handy, very, very handy indeed. But it's a bit, I have to set up it every time I'm opening this save file. So right now, if I'm going here, you see this is the root that I'm specifying there. This is the root, and is nothing here. I clean it. By cleaning, I mean I'm selecting everything and press delete, and deleting manually and everything, and skip everything that is already functioning, like this process thing and whatever. But now, if I'm running the program, so I'm using this verify button. Is running the program, is compiling the program. Now in this folder is making a build here with this number, and inside it I have this file, test.ino.hex. This is how is, you see, test.ino.hex. And this file, I have to load it here in my Arduino, in my Proteus. So this is the root that you've seen, and I only have to change this number, because that number is changing every time, absolutely every time when I'm starting the Arduino program and when I'm compiling it. But the trick is is only starting like that only when the program when I'm first compiling it. The first compilation is creating this folder with this number, with this random number, and this random number I'm putting it there. Well, instead of changing the entire root, I'm only changing that single number, but you have to change that entire root with that file in it. From here, of course, you choose it from here. This is the file test.ino.hex. You see, with the hex in the end. That's what you want to have. And press OK. And now it should work when I play it. Yep, it's working. And this is the virtual terminal that I'm having here, but I will get to that. What I wanted to show you is so this file is not working if I'm not having this Arduino program running in the same time. That's a big of an issue, but it will be very handy, and you will see it in a moment. But back here on the, like I said, like this is the basic circuit that allowed me to actually understand what the fuck is going on with this start pin and this AWOC pin. Both these two pins are used for interrupt. Actually, only AWOC is used for interrupt. But originally, I believe that start and AWOC are linked together and they are used together on the Arduino board. And let's see some. So I did a lot of tests. Trust me on that. With the diode there, as you can see, you see here I linked pin 6 and 7, start and AWOC. Both of those I linked them to the Arduino because I didn't know how the hell this is working until I discovered that this start pin is actually an input, and is here. If I'm going to open my ADC0808, this one. So here, as you can see, this is the start pin here. So this is the start pin. This is AWOC, end of conversion. And it's saying clearly here, it is an interrupt pin. But I didn't notice it in the very, very beginning. But while I was staying and trying and errors a lot of times, and after I figured it out, then I remember I've seen something. And when I opened the datasheet, I noticed this is specified here as an interrupt for this specific AWOC pin. AWOC. This is the AWOC. And they are both, and also the clock. Notice the clock here is also inside this control and timing module that is dealing with all these 3 pins at once. And then the result is sent to this other module here, to this comparator that is having there, on this and then to this output. So it's sending 3 outputs. Well, the same result actually, sending it 3 ways, most probably. From all these 3 pins that it's having here, pretty much that's the idea. But I didn't really see it in all my trying and errors that I did, a lot of permutations that I did until to understand how to link it to the Arduino, because I didn't see any paper, and also in datasheet is not specified at all how to actually link it to anything. So this is my way of linking it. So this let me actually center it like this. So this let me I did play it, right? So now let's test this. This is a test circuit that I'm having here for testing this output and this input, the start specifically. This circuit that I made here is specifically made for testing this start pin and AWOC pin, specifically for these 2 pins. I made this entire circuit to make it work from those 2 pins, to understand them, what they mean, and how to link them. And I did understood them, and I will explain to you. It's a bit complicated, unfortunately. I have to. So now when I'm pulsing, when I'm clicking, it's doing this. You see, it's cycling through 4 outputs that you are seeing here. Right now is reset it to 0, to input 0 that I'm having here. But this input 0 is linked to ground. That's why I'm having this all full on output that I'm having here. So the counting is starting from input 1 that is linked to that potentiometer there. So when I'm clicking this this start pin, the signal is becoming 1, as you can see, and then is getting automatically back to 0, to the ground on this pin. So pretty much I'm holding this pin to ground all the time, and when I'm clicking it, I'm bringing it to high, and releasing it is coming back to 0 pretty much. But this is also creating a clock. This button that I'm doing here is performing is behaving like a clock. So I link it to the clock of this binary counter that I'm having here. 7493 is a binary counter. This part of the circuit is only a simple flip-flop to show me when a stage, when it reaches 5, it will flip 1 time the flip-flop, and when it's reaching the other 5, the next time it will switch off the flip-flop. So this is only to check, to keep in check this little counter. Pretty much that's all this part of the circuit is here doing. But this is very important what I'm having here, because this is cycling through all these 3 lines. It means address ABC of this chip. So what I'm having here is a binary addressable pins. So I can address in binary 0, 1, 0, 0, 1, 1, 1, and so on. And that's the flow. How this should work. This is the mechanic. And I have only 3 pins, 2 to the power of 3, and is 8 permutations. I have 8 addresses in total. For all these 8 outputs that I'm having here. So that's the meaning of these 3 lines addresses. And this counter is set up with these 2 diodes here. It's set up to count only to 5. And when I'm pressing here, you will see how it will count only to 5 and it will reset. Right now it's somewhere, I don't know. Right now it's on 0 and it's resetted. Actually, this it will count as 1, I believe. But let's see, 1, 2, 3, 4, and now reset, which it counts as 5, the 5th. And that's the reason I leave this input off and not link because of this reset that is happening here. And when it's reset to 0, it will switch to this. I know it's a bit weird how I link it, but in this case, but I was following a logic, and it is easier. It's a bit easier to see to understand the inputs. Input 1. When I'm pressing right now, it is giving me, you see here, this is input 1 right now, here. And also here on the display. But I think I changed it a little bit. Well, I changed it here to actually display the 1, 2, 3. The LEDs to display them as 1, 2, 3. So that's this wire is doing, and what is this module is doing is counting between the addresses in binary to actually change the address, and on each address is an input. So if I will have more inputs, I will have more addresses here. So for address 1, I will deal with input 1. Pretty much. Address 1, 0 will deal with this input 1. Address 01 will deal with this input 2. Address 11, which is the third address, will deal with input 3 and so on. And pretty much, when I'm pressing this button, I'm cycling through these addresses. You can see them changing here. You see, this is address 4. This is address 4. And this is resetted because it's 5th, and it's reset to 0. And when it's reset to 0, it's actually calling the address 0 inside this ADC, and this address 0 is actually called. And if I'm linking something to it, it will read it. So that's why I leave it alone for this experiment only. And I use the other ones that are a bit more intuitive to follow. So back to this thing, to this. So this is the functionality, the overall functionality of this circuit that you are seeing here. This is how it's functioned. This is how I thought of using it. This is how I designed it, because this is my design after all. And let's focus back. Let's get back to these 2 pins, because it is about them. So I was actually trying to understand what this start pin and this AWOC pin means or doing. Well, as a parenthesis, let me actually show you. This is this ADC is functioning with a clock that I put it at 10 kilohertz. Actually, in the data sheet, so clock frequency it's minimum 10 kilohertz in kilohertz here. You see, and typically is 640 kilohertz, and maximum is 1.2 megahertz or 1280 kilohertz. So I tested with all of this, with all these 3 values actually. I didn't got in between. With 640, I tested it with 1.2 mega, and all give me exactly the same result, exactly the same behavior. So I stick with 10 kilo because in any experimentation, if you want to test something, you have to run it slow. This is the golden rule. If you run it slow enough to see what the fuck is going on, to understand what the fuck is going on. So that's the clock of the ADC. I will use a separate clock for this manual button that I'm using here, and that will be here in this situation. This clock is at 10 hertz, not kilohertz, but 10 hertz. It's like pressing my button a little bit more faster. It's interesting that if I'm clocking it too fast from here, it will not work very well. So this is not made to be clocked very fast. It's made to be clocked from time to time, pretty much. So that's when something is up. It's not made to change the addresses very quickly. This is my observation until now. So let's run it. And this is the behavior that attracted my attention, and actually it made me understand what is going on. So right now I'm keeping this pin, the start pin, I'm keeping it to low, to 0 volts, as you can see. But AWOC is high. You see this red square here is kept to high. This is 5 volts here. And when I'm pressing it high here, let me actually change it. When I'm pressing it high, the start pin gets high because it's receiving 5 volts here. But AWOC immediately, spontaneously gets low at 0 volts. So this was a very interesting hint that make me say, aha, motherfucker, I think I get you. So when you see how instantaneously is changing, you see when I'm pressing here, it's changing. Let me actually stop. No, it's not. It's not showing. Or let me stop the clock by raising this connection here to only concentrate on these 2 pins. So when this is low here, this is high. And when I'm changing this, it needs the clock, motherfucker. It needs the clock. That's why it needs. This is the reason why it needs the clock as a device. The device needs a clock to actually change very quickly between these 2 pins. I believe. So you see when I'm changing, it's changing spontaneously absolutely in the same microsecond. It's changing to the other polarity. You see, pack. So, but I believe inside this module, like I showed you here in the diagram, is not shown. Or probably I need something else to actually see what is inside this control and timing box that I'm having here. They are linked together, all these 3 pins. I believe 2 things might be inside. It is either between the start and evoc is either a inverted gate or a not gate. Inside, I believe it's either one of two possibilities. Is either this not gate inside is a simple not gate that is flipping. When I'm flipping this to positive, automatically this pin evoc is getting inverted by this logic gate inside, or some mysterious calculation is made probably, and is inverting based on some weird or fancy or something calculation. That's the two possibilities. Something is calculated and is inverting that pin. So what I mean is that when I is this pin, the start pin is getting high, is calculating something, is calculating the addresses, and then is transmitting on the evoc pin that he finished calculating the address and the value that is coming through that particular address, is finished calculating it, and then is sending the signal out, signaling on evoc pin that he finished converting whatever he was doing inside, and is you can use it after that on your microprocessor, on your Arduino, on your logic gates module that you have there, or processor that you are linking to this interrupt pin evoc. As you can see, is actually called interrupt. So that's the explanation that I can think of. So it might not be a simple inverter like I just show you. It might not be just a simple inverter. It might actually process the stuff first in a fraction, in a nanosecond, very quickly. It will process everything, and then output the result out and telling you, dude, I finished the process. You can continue. You can read me that everything is ready to use, pretty much. So that's the two differences that I believe it might be inside this box. You understand my logic. So this was the test circuit for these two pins to actually figure them out, to understand how to link them and what they represent and how to use them. And after I understood the mechanics, the circuit, then I link it properly this time to the Arduino. So it's only one wire from evoc pin to one of the interrupt pins of the Arduino board. And here is another problem. Let me so this is another problem, because all this section is dealing with the boards, various boards with fewer pins or multiple pins, more pins on the board. And my board is a medium board, I believe. Uno R3 is what I have. Revision 3, it means R3. But other boards I don't care. So on my board Uno, I have digital pins usable for interrupts, it says here, you see. And this, my Uno board that I'm having here, is using only the pin 2 and pin 3. So 2 pins is having, specially dedicated for interrupting. So actually the processor is dealing with this interrupting mechanics, and that's very interesting and very important. So it's done. The interrupting is a hardware thing. It's a hardware, and you can access it in the software, in the program, and use it as a separate loop, as a secondary loop, pretty much. It's my understanding is the behavior, how it's working. It's very interesting, and an additional thing. So let's say you have a lot of code here in the main loop program. By the way, this is the main loop function in Arduino and is not used for interrupt. So I had to actually read very carefully the entire this page, all this entire page. I had to read it fully, entirely. And there are a lot of precautions and notes and warnings, what to do, what to not use, what to use and what to not use. And it's very important to read this page first, to actually understand it, to understand the function inside the Arduino, the software side. So let me explain it a little bit. What an interruption means. An interruption means when you have a lot of important code that you have to use it inside this loop, that is the main function of the of an Arduino program. And like in my case, this is signaling high and low. This evoc pin is signaling at some point. And when that signal happens, I have to deal with it inside this loop. I actually did this in my previous tests that I did. ADC, not the here in this 9. I will open it like this, and you will see here void loop. You see inside this loop, the main loop that I'm having here. I put all this code, and I'm running inside from this loop. I'm running it, and it's working. It's working with this arrangement. So when you have a lot of code, some important code that is running inside the main loop that you have in Arduino, you have to stop from the main loop, read whatever input is coming from some important device like a button press or a wheel that is spinning probably. Read that and then come back to the loop. And when this is done inside this main loop, it might not work, or you will have to make a lot of code to get that functionality. And it's very helpful to actually understand it and use this interrupt. So this is the arrangement. What I did here, I only linked the interrupt pin, the evoc pin, to this one of these 2 pins, special pins of the Arduino board. You see here is actually in the name. You can read it. It says int 0, it means interrupt 0, and int 1, it means interrupt 1. And only these 2 pins are specially not 1, not 0, because these are the first pins. So pin 2 and pin 3 here, so this and this, these 2 pins are specially dedicated for interruption on Arduino. Okay. So what I did, I linked this ADC pin, which is specifically for interruption, to one of these two pins of the board that are dedicated only for interruption, pretty much. All right, this is the hardware part, and the rest of the circuit follows the same logic as I made it here in the test circuit that I made when I had to understand what is going on. Okay, so so the same goes here as well, but when I'm pressing here is cycling through the bits, exactly like my test that I did there. But here is the thing that is doing, and all this trouble that I get into it. Let me open virtual terminal, which is you must have this component inside this viewport, and then open this terminal. This terminal is linked to this component that I'm having there. So when I'm clicking here, I can see the actual values that are displayed here. So I only concentrated only on 4 bits for the moment. So 4 output pins here, it means 4 bits, and they represent these 4 bits here. So forget about these other 4 pins because I didn't link them. You see here, I didn't link them there to anything. So only the first 4, these 4 are linked. And as you can see here, this says 1000, and here is 1, which is positive. You see this one, and the rest are off, and they mean 000. So 1000 is this. You have to read it a little bit inverse, but there is the same result, both of them. So it is reading exactly perfectly. So that's why the trouble I get into it to make all this program to actually display and make a list of all the outputs that I'm getting from the ADC, pretty much to have a list. So when I'm pressing next, it will update the list, it will add to the list the next segment, the next bit fragment. So it's 1100, and you see it here. You see it here as 1100. You see 11 and 00. And let's cycle next. Next is 311 and 10, and as you can see there as well. And this means let me close this. This means we are at address 3 because I changed. This is what I mean by good sequence here. 16, 9. You see, 16 value for here, 9 for here, 1 for here, and 13 for here. To actually display here on the LEDs 1 LED on when the address 1 is activated, 2 LEDs on and 2 off when the second address is activated, 3. And the fourth, I didn't want it to make a fourth, and I made a weird. You see, this is fourth. It doesn't matter. It's just only for tests right now. This will change. These values will change, but for now they are constant because I'm testing at the moment. And while I'm testing, I really don't need this to be a variable. I want it to be a variable, but variable enough to allow me concentrate on more important things. So that's the idea. Okay. Now let's get into the code. So you understood how I linked this EOC here. A friend of mine, I was talking with him, and he asked me why did I use these inverters here on these lines. Well, simply because I have a plus 5 volts here. As you can see, the sense of the LEDs from 5 volts. The 5 volts is surging through the LEDs in this direction, and is surging through the pin of the ADC to the ground. So the ADC output is actually surging the current instead of sourcing the current. So this is not positive. This is when this is negative here, is allowing this LED to open. And pretty much I made this side of the output, this side of the inverters positive. Here. When this is getting negative, this will be positive. So I will have a positive input into the Arduino, and Arduino will read it correctly. Not to have very weird programming code. Not to have a weird code that will have to deal with negative instead of positive. Pretty much. That's why I inserted these simple inverters here that are helping the code, pretty much, are helping the code to understand what is going on. If I will have to do it in reality, probably I will do it a bit more complicated than it is right now. But right now, for the sake of clarity and understanding exactly what the hell is going on, I will put everything inside my circuit just to be clear, crystal clear. Okay, all right. Here I put an oscilloscope to measure these inputs, and I can show you actually. Here, when I'm switching to automatic, this is cycling through 10 Hz, and we can see where are you? So get on 10 now, and we can see automatically running. And I was checking with this automatic clocking that I'm having here. I was checking for errors, and I do get an error. If I'm switching back and forth, you see, multiple times, I will have a string of error. You see, let me actually pause it. Oh. And you see this? This is an error here. It shouldn't happen like this. But if I'm fucking with this with this switch here, let me actually point it big with that switch between off. Between negative or positive, doesn't matter what is here. So it doesn't matter what is here. It's either negative or positive, but it will add an error. Random, not random, but weird, very weird readings, and not in the proper sequence as you intended. So don't fuck with that switch there. Don't switch the pulsing with the normal. Or if you do, be aware that is an erroneous beginning, or erroneous start beginning, and then the code will go correctly, will behave correctly. And so this is when you switch and to automatic, to automatic, and it will run correctly, or to manual, doesn't matter, or manual, doesn't matter. And when you will switch it on the other side, whatever it is, it will also create an error, this error. And so in the beginning and in the end, here. So in the beginning and the end, it will add an error in the moment you will perform the switch. But in between, if you leave untouched this switch, it will run smoothly the code. It will absolutely be no problem. So that's an important thing to actually mention it, because there are a ton of stuff that I tested. It's good to know. It's good to know this stuff. I was saying I wanted to show you the oscilloscope, because the oscilloscope helped me very well in this particular case, because in my previous testing I was getting a lot of errors. I was getting double information, a double bit sequence, as you can see here. This is part of an error as well, until it will get to normal. This is normal, this is normal, this is normal, this is normal, but this is a little bit of error, see there, and that little bit of error, I was getting it all the time, that kind of double values, one after another, and then it was normal, and then another double for everything all the time. I get at that point in time when I was getting that error. I was believing these outputs, well, the outputs of the ADC are introducing some double signal, and I wanted to check it. So that's why the oscilloscope was quite good to test if I'm having double signal on the outputs here. So I switch it back to manual, and when I'm clicking once, and let me pause it, I was checking if I'm having zang zang. You see, two blue or two red or two green, one after another. And if I was getting two of them on the same line, right now they are only one drop. You see, it's only one drop or raise, whatever it is, raise or drop, but one change in polarity. And if it's only one change in polarity, it's good. But I was expecting to see two changes, one after another, very quickly, pack, pack, or on the rising edge here, pack, pack, you know, and to see double. It wasn't the case, so this told me that the output signal that was coming from the ADC was correct. Is only one per each segment, pretty much. And let me stop it. So that's what this oscilloscope means here, and I leave it here all the time in the idea that maybe I will use it later. Okay, now the code. So this is all the hardware that I use. I explained it the best I could. The code depends on the wiring and the hardware that you are making here. If you are not connecting the hardware correctly, the code will not do anything correctly as well. But if you are connecting anything correctly and understand the logic, the code will behave, and it will give you the correct logic. And it will give you the correct output, as you've already seen so far. So this output that I'm getting on this terminal is the actual code that is in this Arduino sketch that I'm having here, program. Okay, so let me actually show you. I made a lot of tests, and also a lot of hardware changes. Like I told you already in the beginning, I didn't know how to link these start and EWOC pins to the Arduino pins. I believed both of them must be linked, but after a while of testing, I did manage to figure it out. That is only one single line there, and this is the proper way, exactly as you are seeing here. Is not different. It's actually a screenshot of what you've seen here, and so the code is actually following this particular hardware arrangement that I did here in these screenshots that I'm having. So let me get back one step back and open this, because I showed you already, but I will show it again because now is about the code. So it's very important to have a serial begin. This little it's very important detail, especially when you expect an input. When you are waiting for inputs, this serial begin is very important to have it there. Without it, it will not work anything. So I had to figure it out that this is very important thing to have when you are dealing with inputs. So what I did here in the code, in the setup, I made the settings pretty much. I created the settings. So the settings, I set up pin 13, 12, 11, and 10 as inputs, because they are this four lines, as you see here. These four outputs from the ADC that are converted for an easier read in my code, are converted from negative to positive, and when the pin is activated. And these are the pins 13, 12, 11, and 10. And I just declare them. This is the declaration. I declare them as inputs. And on this pin 2 is also is pretty much like this one, but I put a space there too, because this is an important pin. But actually, in this part, in this code that I'm having here, is not used as an interrupt at all, and is used as a normal pin. Instead of using it as an interrupt, I use it as PD2, as you can see it here. I was linking it correctly to interrupt 0 pin, but I was thinking the mentality was as I was using a normal in-out pin. That's it, not as an interrupt pin. So that's the difference. Next, I declared a global string, group 1, and a global boolean, which is true or false, is read once. And this is the loop function, which is dealing with repetition in the code. That's it. These are the two main important functions inside this program, inside any program in Arduino. You must have a setup function, and you must have a loop function, and that's it. Your program is done. You have to insert some data some settings into the setup, which will run only in the beginning of the program, when the program will start only once, and this will be the repetition side of the program when everything will repeat. And this is a function that I made. Actually, I didn't make it, someone else made it for me, because we were testing something on Arduino forums. I got there and I was asking for that repetition that I was having in the code on the output. That was the problem, but it turned out it was an interrupt problem. It wasn't a code problem. And all this code that I'm having inside this loop function, all this code is mainly dealing with showing correctly the output that you've seen on the terminal here. When all the displaying one on top of the other, let me actually, not you, here. So when you see it like this, you see this is displayed as follows. Is displayed as one on top of the other in line, one in line of each other. You see, very nice, very beautiful, like this, and also with a space between them to actually see when one is finishing and one is starting, and one group, of readings when the address is reaching the end and when the address is reaching the start of the address of the ADC, pretty much. And also on top of the other, because in the beginning it was in line, everything in line. It wasn't nice to. It wasn't, you couldn't understand it, pretty much. So all this code is dealing with string manipulation. This is all that is doing, is string manipulation. But if you see here, where are you? This is the only line that is actually sending to the terminal this string data that is already, all this prepared string shape or form is inside this global variable named group1. Actually, the group, what I mean is a set of 4 numbers. That's it. That's the group, not the entire full start and end of the address. So it's a bit misleading. But I was thinking on the group of the bits. I should have called it a byte. This is a byte of 4 bits. But yeah, I call it group. It's not wrong. But it is a bit misleading in this case. So name it correctly in your code if you are doing it. This boolean, I put it here only when the input pin, when the signal is getting high, only when that is high, all this stuff is executed. But if that is low, this variable is set to true. And if this is set to true and this is set to high, then read everything that is inside. And also reset this to false. Why I introduced this is read once here, because of this problem. So that was a very important thing to deal with. Let me run it. So when I'm pressing one time here, you see it displayed only one time. And this one time that is displayed, and then the next sequence is displayed, which is different. You see, it's different and it's only one time displayed. But here, without this global is read once boolean, without it, it was running it because it's in this loop that is repeating forever. It was repeating it forever. So setting it true and false. So when I'm setting it false here, even the pin is high. Even when the pin is high, this will get false because it is only read once. That's the only logic. And when the next pin, the next reading, will get high, when the next reading will perform, when the pin goes low to low, is cycling to this and is resetting this to true. And when it will go high again, it will be already true, and then reset it to false, and only read only once. And that's the logic of the code that I'm having there. So it's not really that hard. And the binary read is used here and here. You see, binary read here and also here. It's only reading one by one all these input bits that I'm having, input pins that I'm having. One by one is reading first the 13, 12, then the 11, and then the 10. So it's reading them one by one. And this is an if-else sequence. If the pin 13 is high, this string named out gets 1. Else, this means else, is 0. So but it's a shortcut of an if-else syntax that I'm having here. It's called operators or something. I forget it now. So this all that does is reading all those 4 bits. That's it. That's the entire, and is a string and returning also a string, and that's why I could use it here as a string. So if this is giving me a 1111 in this case, does this stuff and reset and perform and make a double return, a new line. This error, it means return, but it also means a new line. So make a double new line, make 2 new lines to make a space between them. So this is the code analysis. So why I wanted to show you this code is because originally I used without the interrupt function, that is inside Arduino. So it worked. It worked like you are seeing it here, absolutely fine. It worked. It was a bit hard for me to actually transfer to think how to transfer from this form into the interrupt form that I'm having here. So I discussed already this code and what it does. So this is the in-out reading of that is the code that is dealing with in-outs pretty much, but not with the actual interrupting. But this code that I'm having here, and is the last one here, the backup 10 that I'm having right now. So this is actually dealing with an interrupting function inside Arduino. As before, this is the setup when we are setting up the pins. But so this is the exactly like before. I set actually let me have it open here for comparison. So side by side to see the codes. So this pin is internally pulled up. This is a special function that they have in Arduino that is working fine with input or input line pull up. But it's the same thing pretty much. It's a minor difference. I'm not sure how important it is. I'm not sure. So, but this is for pin 2. Where are you? Pin 2. Here it is. For this pin. For the actual interrupt pin. So I commented here, you see, as AOK output from the ADC, but input for the Arduino and special interrupt pin as int0 on the Arduino board. So this is a reminder. This is setting up this pin as an input. Okay, and then this is a special function that is only run once and is set up only once in the beginning. And it's having so this is an interrupt handler. This is the interrupting function that is handling the interruption pretty much. That is creating, that is doing, that is waiting for an interruption to happen. So this is how I understand it at least. And as you can see, after I read all this page that I'm having here, that they suggested me from the Arduino forums to read it. After I read it, I understood what I have to do and what I don't have to do. And as you can see, originally I put everything, when I was reading in-outs, only the in-out pins, but not the interrupt pin. I was reading it inside this loop function, you see, only in this function. But here the loop function is empty, absolutely empty, because this is the interesting part of the interruption, that is not using this loop function anymore. This loop function, the main loop function in Arduino is used for something else to have it run at the same time. You know, it's like two separate codes you have. So in the main loop that we have here, you run something, I don't know, important. And this is a secondary, the actual function. You have to create a void function. It does so it's having a set of rules. So I make some notes here. This is a normal function passed as an argument into the interrupt handler. What this means, it means that you have to insert it here. So this, let me actually show you the syntax. This is the recommended. You see, it says there recommended. This is the first recommended syntax. How to use it. This is not recommended. This is not recommended. This is not recommended at all, because it's so these two are not recommended. But this one is the one you have to use it. And this because of this other function that you have to integrate it here. That's the only difference between all of these three. This function that is dealing with the pin. So you have to include this digital pin to interrupt. That is internal Arduino function, and you have to specify the pin number or the pin variable. And here in their example that they have here, you see in their example, you see this is the line. And they are calling a variable, but this variable is interrupt pin that is assigned number 2, which is the pin number of the Arduino board that is dealing with the interrupting. In our case, it's either pin 2 or in interrupt 0, int 0. This pin 2 or int 0. So so this is the first argument here. Then is a comma. So this function is having 3 arguments. The first argument that is including also an internal function to which you have to serve. You have to give a pin number here. Then your function that you have to pass, and inside this function is like another loop that he is listening to it. So this function, this parameter that we have here is listening to this function. This parameter is listening to this function. Pretty much. That's it. And this is the behavior. What to do? And there are a set of behaviors here. These are the behaviors or parameters. They are all parameters actually. There are 3 parameters. But let's say. Yeah, actually interrupt. Okay, they should actually modify that into this entire thing, because this entire thing is important. Not only the interrupts simple, that is confusing, and it will lead you to fail. So this argument is you can have it as low, as rising, as falling, and on some particular boards, the high argument will also work. In here it says that it will work only on these boards, but it worked with this parameter. It worked on my Arduino Uno as well. It worked when I tested it. But the difference between change and the other ones is that the other ones are changing only one time, but with change is continuous, is doing the correct job pretty much. These are special cases, low, very special cases, so you don't have to really deal with them. Only if you really have a special case, then you have to test them. Use the change and you are good to go, pretty much. And that's it. These are the 3 parameters that you are using here. And inside this special function that I'm having here, that I pass it into this interrupt function handler, whatever it is actually the exact same code that I'm having it in the loop here. So in this loop that I'm having it here is exactly the same code, is exactly here. That's it. The only difference from this part and this part is that I comments to explain what the hell is doing and how to use it. So this is a normal function passed as an argument to this function that I'm having here, to this handler. Only the void type is allowed. So you are not allowed to make it as an int function, as a string function. Is not returning anything. Those functions are returning a string, but this void function is not returning anything. So only void type is allowed. It is exactly as you would use a secondary loop function, like a loop 2. To make a comparison between the two. Think of it like it is like a secondary loop. But in Arduino, only one loop function is allowed. This loop function is allowed in Arduino, only one. The interrupt handler listens to pin 2, meaning this function here. This is the interrupt handler. Is listening to pin 2 and execute this function, this into function, when that pin changes. Other parameters are for one-time use. This I already explained. So use change parameter for continuous feedback. Pretty much is what I just explained earlier about this difference between them. Use only the change one because it's continuous feedback. The other one is only one use, and it's special, very special cases. And pretty much this is the binary read that you read every bit one by one. And yes, I believe I covered everything. I hope this is the result of that code. It's exactly what you've seen so far, and it's not working because I have to recompile it again with the change parameter that I'm having there. I'm recompiling it, and now when I'm running it from here, it's running it back as it was before. This is very important change. This is a very important setup that I did for Proteus and Arduino as well. In Arduino, if you look here, after you compile it, after you compile the code, you get this scroll a little bit further to the right here, and not elf. Do you see this elf.elf? This one here. Do you see this root? This is the root that I'm using here. This is where I looked, and I copied this root, and I navigated here in my computer. And in my computer, I am in that folder, in this temporary folder, that this Arduino build, this Arduino program that is now open, it is creating a folder here. And inside this folder, actually multiple folders, this Arduino cache is creating as well, and probably a file for somewhere, either this one or this one, whatever, which we don't care about them. But we care about this Arduino build folder that he is creating. And this is a temporary folder, and he is running all this code in this temporary folder that is having. And he is also converting automatically and automagically is converting the hex file that you see here, this test.ino.hex. This is very important because I'm referencing this file, this hex file inside. I'm referencing this file inside here in the program, in the Arduino program. And when I'm compiling the program from the Arduino program from here, when I'm pressing that button, and right now it's compiling, and after it's finished compiling, is writing the compilation into this hex file as well. Also, all these files are updated, are erased and replaced with other ones that are new. But also this hex file as well, which is very, very handy to have it like this, because this is reading that file automatically. Is reading that file, that test file automatically every time when you press this button. When you press this button, you compile it, and then switch to Proteus, press run, and is already reading that file that is already compiled. Extremely, extremely handy. But the downside is that you have to set it up every time you are opening this Arduino program. When you are opening, is creating a new folder here with different number. That's very, very unfortunate. Very, very unfortunate. It would be very nice to actually keep this number constant, but it doesn't. So I'm only copying this number. Let me actually close it and show you. So I'm closing that Arduino, and now this program will complain, will throw me a big error, and will say, no, like fatal simulation, motherfucker, errors encounters, view the simulation log, and something that unable to open hex file. Yeah, you see, it's actually telling you. This is a good error, but usually it's throwing you some stupid errors that you cannot understand. So pretty much this folder is no more here. You see, in temp folder, everything is erased, is no more. It was temporary. That's why it's called temporary. So when I'm opening this file again, now it's opened, and now in this temporary folder, when I'm clicking, no, it's not when you open the program, it's not creating the folder automatically. You have to compile it first to make a first compilation. Okay, now it's finished compiling it, and now when I'm clicking here, is updating with the new build that he made. And this number, this is a random number that he is creating, is generating it. This I copied from there and inserting it here, like that. Press OK, and now when I'm running the program, no error, and everything is back to normal. Yay! So that's very, very, very useful and very practical, and this is how I could work. And I had to keep this test file, this Arduino program open all the time, and change the code. And then I had to copy and make a double of this code and make a backup with this from this if I wanted to make it as a backup 11, let's say, like this, and I make it a backup 11. Of course, you don't you are not allowed to have multiple .ino files. Here, let me delete this file here because I don't need. I only showed you how I'm making these backups manually. I'm making them. Just copy this, making a double of this file, and then rename it. And be careful not to leave the extension, the .ino extension, and not leave it there because it will not work. The program will not work. You have to be. It has to be extensionless. Without extension or with something other extension, doesn't matter. It can be .jpeg, .text, txt. You see, I have a bunch of txt text and a bunch of JPEGs there. It doesn't care about them, but he is caring about if it's another .ino inside the compilation folder that is into. So that's it about the folder specifications. And I really hope that I covered everything. I really hope you like it. This is a strange and a bit hard to explain, and that's why it took me a bit of a long time to explain it in depth. And I'm sorry for taking so much time, but it is how it is. You are learning something absolutely new and absolutely specific. This is a very specific thing. The ADC is a specific component. You are using it not that often as you might think of. So it's a very specific component. Arduino board, or well, it's kind of a general. But this interrupt function is also a very specific function, and with its specific pins, its specific hardware links and connections, and it's quite a specific subject what I'm having here, and it's not that common. It's not that widely used. But for some people, probably it will be helpful, and you see my way of doing things, how I'm testing. This is why I'm showing publicly. Is what I'm showing. Actually, I'm showing how I'm doing things, how I'm testing, how patient I am, how I'm testing multiple times, not only one time and give up. I'm testing multiple times until I get the result that I want. I'm asking people around if I have good people around, and I can find those people, good people. I can find them on forums, usually on electronics forums for electronic hardware, for integrated circuits and how to link and how to connect everything. I'm using the AAC forums, but not only. Other forums are good as well. Some English, UK, and the American forums, but Americans are weird. Some are very, very weird. Also the English are weird. The UK ones, but everybody is weird. Probably I am weird as well. Who knows? I don't consider myself weird. I consider myself very normal, but yeah, well. Okay, so this is it for this part. I hope you like it. I hope you understand it, and I really hope it helped you in understanding this special thing, because it is a special thing. All right, from Romania. From our favorite artist electronics here, Mr. Q12, the best of the best artist on the world that is knowing a lot of stuff. But in this capitalism, the Putin Russian capitalism that we are living, the Chinese capitalism, the American capitalism, or European capitalism that we want to believe they are our capitalists, but actually we are driven by the Chinese and Russian behind the Chinese. It's a Chinese capitalism that is is promoted and is demonstrated. This is a demonstration of how the capitalist should work. But in this capitalism that is not working at all, I cannot get any jobs with all the stuff that I know and all the knowledge that I have, and doesn't matter how good you are, especially in this capitalism that we are living right now. Doesn't matter how good you are, you will not succeed if you know too much. If you are stupid, if you are young, if you are a woman, probably, or a child, you have a lot more chances to get employed. And if you are very stupid, that's very important. But if you are too smart, if you know too much, people get scared of you. They get intimidated, and when they get intimidated and when they get scared of you, they really don't want you around them, because they cannot cheat you, they cannot steal you, and they know it. And that's why they need stupid around them, idiots, very young, very unexperienced people. This is the way of capitalism, unfortunately. And you cannot. That's why I'm staying home. I am unable to get any job. I'm applying to a lot of jobs along the years. I applied to a lot of jobs, but none actually responded, because they are either fake or job interviews or whatever they are. They are either fake job announcements, or either they really need some traffic on their website when a lot of people are subscribing and posting their CVs and asking about and they feel important, and they have a proof. They can prove they are solicited. They can prove they are searched. They can prove they are asked by many people, and they get money because of that from the government, most probably. I'm not very sure how the wheels of capitalism are working exactly, but some people are doing some very, very weird, from my point of view, weird stuff, and usually the smart people are not easily getting work. They are getting the shitty work, of course, but the good stuff, the good work, no, no chance. And yeah, it's a lot of competition. Most probably it's a ton of competition and a ton of idiots out there. And yeah, that's why I'm saying all the time, in capitalism, doesn't matter how good you are, you will never succeed. It's impossible. Yes, I will leave you with this. Thank you very much for watching, for hearing me, for staying with me, and see you later on the next one. Until then, bye-bye from your favorite artist electronics. Bye-bye.